Hello, everyone. It's Mr. Shajoy here, and you know what time it is? It's maths o'clock, right? So, welcome to Back to Basics Learning Institute. So, now what we are going to be looking at today is we are going to be doing factorization, right? So, I know this is one of the, simplest and easiest component when it comes to algebra, right? So now we are going to firstly try and understand in terms of what are some of the steps of factorization, right? Because we want to do the very much basics so that we can understand in terms of what do we do when we factorize. Now firstly, we are saying now factorization can be understood as what is basically an inverse operation to a product, right? So it is going to be your inverse operation, to a product. I know that probably this might not necessarily make sense to some of you now, but basically it is an inverse operation to a product. Now, for example, if you're having 2x plus 4y, we are saying how can you factorize this, right? They say factorize this. So now for you to factorize, this is going to be same as 2 into x plus 2, right? So we are saying as long as you are able to write this, to change this and write it in this format, then which means we are saying now you have factorized. Are we together? And, so that you can also have the ability to move from here and then you multiply it back here so that you can go back to your original sum altogether. So if you're able to do that, then that's what is, factorization. But we are going to look at more, things that have to do with factorization. Now, the second thing is now, if let's say you are given your binomial, and remember we said a binomial, it's what? It's two terms, right? Binomial, it's two terms. So now what is it that you are going to do? If you are given your binomial, what is it that you can do? For example, when factorization, you can probably look for, what? Your different of two squares, or your what? Or you can look for your different, of different of two cubes, right? Of two cubes. So now different of two squares can be example, let's say a squared subtract b squared, right? Remember, difference is represented by negative altogether. So when you have a square number, subtracting a square number, then it gives us your different of two squares, right? So these are some of the things that we do when we factorize. Now let's see in terms of what else can we know. So now when you are factorizing, now you need to also check if, let's say, you are given your trinomial, right? Now, a trinomial, it's what? Three terms, right? It's when you have three terms. And remember that terms can either be separated by what? By a plus or a minus. Sure. So now let's say you are given a trinomial. So you need to check whether is this trinomial given in terms of ax squared plus bx plus c. And if it's given like this, then you can be able to, factorize this by, opening your two brackets and finding out what is your solution. For example, now let's say you are given that you are having, x squared subtract 3x, subtract 3x plus 4. They say factorize this. How can you factorize this? This is going to be same as x, open two bracket. This is going to be x, and then you're going to have 1 and 4 because those are factors that can give you 3. And then what is it that you can also have now? See, since you're having a negative here, since you are having your negative sign here, right? So which means this is going to be negative and this is going to be positive altogether. So you have now factorized your trinomials. So that's what we mean when we say you open your two brackets when factorizing trinomials, right? So now let's try and make up some space here so that we can be able to, if let's say you are given 4 terms, right? So if, let's say, you are given 4 terms, now you can do what we call, factorize by grouping, right? So, but this is probably when you're given 4 terms or more, 4 terms plus, right? Factorize by grouping, right? So now, how do we then factorize by grouping? So we factorize by grouping by firstly, trying to find the pattern. What is the pattern in which those terms of ours are they given? How to get from this pattern, for example, from this pattern, do we have different of 2 squares? Do we have different of 2 squares? Or do we have what, or do we have what we call perfect squares? Perfect square. Do we have all those things? If yes, then we can also be able to factorize this out again. So these are some of the things that you need to, take into cognizance when it comes to factorization, right? Now, one thing that you need to also not forget is that you need to factorize fully, right? Factorize fully. Now, which means you factorize it to an extent whereby there is no any other thing that you can do to factorize this altogether. For example, let me just give you an example of some of the students' mistakes that they do when it comes to factorizing full, right? Now, let's say you are given that you have two, let's make it 4. Let's say you are given 4. Let's change this and make it 4. Where is our rubber? Yes. Let's say you are given, let's say now that you are given that you have 4x squared, right? Subtract let 4x squared, let's say subtract your 8y, 8y, right? Now, what is it that we can do here? Look, now some of the mistakes that students they do is that they will take out 2 as a common factor, which is indeed correct. 2, and then they remain with x squared, subtract 1. This is must be subtract 4, right? And this indeed, when you multiply back, you still get what you are given. However, is this factorized fully? No, this is not factorized fully. What is it that we require to do for us to factorize fully? You need to take out the maximum. You need to take out maximum common factor, right? You need to take out the maximum common factor. So what is going to be your maximum common factor of this one actually? Your maximum common factor here is going to be what? It is going to be 4, right? And then you are going to be left with what? X squared subtract 2y. Okay. Can you see that, this, most students will find this, as almost the same thing, or they will argue that this is factorized. However, whenever you are factorizing, you need to do what? Find the maximum common factor, right? This is an example, right? They say now your example 1. They say you are given that you have 6y squared plus 12y. They say here factorize fully. Now, what is it that you can do? Look, indeed, this is going to be what? Now, you're going to check whether do you have your maximum common factor. Remember, because I said that's what we need to look for. Maximum common factor, right? Do you have that? Yes, look, as much as 3 is a factor on this and this, but it's not a it's not a maximum. But 6, yes, 6 is the maximum. So which means you're going to be left with 6y squared plus what? Plus 2y, right? However, this is most of the mistakes that learners are going to do. Now, is this factorized fully? No, look, your y and your y still have your what? still are still common factors. So actually your common factor here is 6y into y plus, plus 2 altogether. Then yes, indeed, this is going to be your what? This is going to be your common factor, right? Surely this now makes sense. Now let's try and get much more your example 2. And in example 2, you're given that you have 3a into what? Into 2 a subtract b, close bracket, subtract a squared into bracket 2a subtract b again. Now, what is it that we can do now from here? Now we're going to check, do we indeed have a common factor? Yes. Remember that 3a, this, it's same as one term, and this is same as one term, right? So what is it that we can do here? So you're going to say now, if you can take out 2a subtract b as your common factor, what are you going to be left with? You are going to be left with your 3a subtract a squared, right? So now this is what you're going to be left with. However, now if you can look here, can you see that you have a here and you also have a here? So actually, which means you can take out the a, also have a common factor. So which means you're going to be left with a into 2a subtract b, close bracket. The other one is going to be 3 subtract a. Now you have factorized fully. Altogether, now you have factorized your equation fully, right? Now let's try and make up some space here. Now let's check. Let's say we have your number your example number 3. Now they say in this one, look, you are given x into bracket what? X subtract y, right? And now you have what? Subtract 4 into your x subtract y squared. Now, what is it that we can do here? Now, surely there are many things that we can try and do in order for us to solve this. So now, firstly, we are going to now look for a maximum common factor. Do we have a maximum common factor? Yes. Look, here you have x. Let's use a nice color there. Look, you have what? You have x subtract y. Now here you have x subtract y. It's actually 2 x subtract y's, right? Altogether, it's 2 of them, right? So which is, what is it that we can do? Actually, let's write this way. So this is same as x into x subtract y, right? Subtract 4 into x subtract y, which is also x subtract y. Remember this bracket, which means it's 2 of the same thing, right? So now what is it that you are going to have here? Now look, now you can take out x subtract y as a common factor. Now let's try and write a bigger bracket to accommodate everything that is remaining. You are going to remain with x subtract 4 now into bracket x subtract y. Altogether, remember, because we only took one x subtract y as a common factor. So now let's try and continue to solve this. So now what is it that you're going to have? Look, you're going to have x subtract y now into, you're going to multiply everything there. So this is going to be x subtract 4x plus what? Plus 4y. Remember that you have negative multiplied by negative. And then what is it that you're going to have at the end? Now look, you have x and then you have subtract 4x. These are common factors, right? So, or rather, these are like terms. So this is going to be same as x subtract y into what? Into negative 3x plus 4y. Then you have factorized this fully. Usually when we do sign change, it's when we want to change the brackets, so that it matches the other bracket altogether. Now let me just give you some of the brief notes there. One thing that you need to take note of, let's try and get some other nice color. Something that you need to take note of is that now let's say you have what? Let's say you have, you have your B plus your A. Your B plus your A can still be represented as what? As A plus your B. Why is it so? Look, remember, this is same as positive and this is positive. Even when they have swapped them, this is still positive and also this is still positive. Are we together? So which means nothing, they've done nothing there to affect the nature of that. However, if let's say now you have B subtract A. B subtract A is not the same as A subtract B. Why is it so? Look, your B here is positive and your A here is what? Is negative. How is your A here now? This is negative and this is positive. So you can no longer, there is no way that you can write B subtract A as what? As A subtract B. However, what is it now? Now to do a sign change, what is it that you can actually do? Now, for example, now let's say now you have B subtract A. B subtract A is equals to, now this can also be rewritten as negative into A what? Into A subtract B, right? Why is this so? Remember, if you multiply with this negative, let me get another color. If you multiply with this negative is same as what? It's same as negative A and plus B, which is indeed matches this side because here your A is positive, your B is positive, and then your A is negative. So can you see that these two are the same altogether? So please take note of that when you're doing sign change, right? So let's just, get some example while we are still on that. Now, let's say I give you that you have 4A into bracket, A subtracts 2B, close bracket, subtract, 6 into what? 6 into 2B, 2B subtract A. What is it that you can notice here? Now, remember, I said firstly, when you have this, you can check common factors. Now, look, can you see that your A subtract 2B is not the same as 2B subtract A? So now, which means you can change any of this so that it can be, it can be the same bracket, right? So now, how can you do it? We are going to use this method that we are just using now. Now, remember, now your 2B subtract A can be written as what? Your 2B subtract A can still be written as what? It can still be written as your negative into A, right? Subtract what? Subtract 2B. Why am I saying that? Remember, because if you're multiplying with the negative here, look, if you're multiplying with the negative, you're still getting negative A. If you're multiplying with the negative, you're still getting positive 2B altogether. So can you see that this can be represented in this way altogether? So therefore, which means we are going to say now, this is going to be 4A into A subtract what? 2B. Close bracket. Now, remember, because you've taken out this as your negative, so this negative is going to affect this now. So this is going to be positive 6 now into what? Into A subtract 2B. Are we getting it? Hopefully, yes. Now, and then when we are here now, then we can now take out your what? We can take out our A subtract 2B as a common factor from this and also from what? And also from this out together. And if we take that A subtract 2B as a common factor, what is it that you are going to be left with? You're going to be left with 4A, right? 4A plus what? Plus your 6. 4A plus your 6. And now, is there anything that you can still do here? Look, you have 4, you have 6. Surely there's a common factor between those two. And what is going to be a common factor? A 2. So this, your final answer actually is going to be written as 2 into A subtract 2B, right? Close bracket. And the other one is going to be what now? Now this is going to be 2A plus 3 because you've taken out 2 as a common factor. Right now, hopefully this now is making a little bit of sense. Factorizing by grouping is basically when now you are having at least 4 to 5 terms that are being added together, right? Now, let me just give you an example. Let's give you this example. What? Let's say you have 9D plus your BC, right? Plus your BD, altogether, subtract your 9C. And remember the first thing that I said that under factorization is that you need to firstly find a what? Find a pattern. Try and find a pattern. And I said pattern can be also driven by finding whether do you have, anything that is common, or do you have any square, numbers, or rather different of two squares, altogether. So these are some of the things that you can, try and check in terms of do you have. Now, in this case, look, we can start with this one. Look, you have 9D. You also have subtract 9C. This one, it's BC and BD. Surely there's something common in all this, right? So let's start now and, try and group some of this. Now, when we're grouping, look, we're going to say, let's take 9D. And then we say 9D, subtract what? Subtract your 9C. Isn't it so? And then we say, now here, this is going to be plus what? This is going to be plus, what are we having here? You're having BC plus your BD, right? Surely there is something that is common in all these things, right? So now let's try and extract what is common here. Now in the first one, look, and 9, you have 9 here, you have 9 here. So actually 9 is common. So if you have 9 as common, what are you then going to be left with? You're going to be left with 9 subtract C, because, D subtract C altogether, because you've taken out 9 as a common fact. Plus, in this one, what is it that you're going to be left with? You're going to be left with B. Then you're going to be left with what here? You're going to be left with C plus what? This is going to be what, when you take this as a common factor, this is going to be C subtract D. Wait, I think we might have omitted a sign here. Let's rub. Now, remember here, it was supposed to be negative. Let's get a pen. This was supposed to be your what? This was supposed to be negative. Altogether. And what else was supposed to be negative? Now here, this was supposed to be subtract here. This was supposed to be subtraction here. Altogether. Hopefully you still follow. What we've done, firstly, we said 9D subtract 9C plus into BC subtract, BD altogether. And then now, can you see that when you take out B as a common factor, now indeed you are left with B, we're left with C subtract D, because those are same things altogether, because they have something that is common in between them. Now, look, can you take out a common factor between these two? We have 9, D subtract C. The other one is what? It's B into bracket, C subtract D. No, you can't, right? Because these two things here, this here and this here, are not the same. Now, how can you make them to be the same? Remember that C subtract D, you can write this as what? You can extract, you can do what? You can extract a negative here, and then you are going to be left with D, what? D subtract C altogether, because when you multiply this back, can you see that it gives you what? It gives you your D. It gives you a negative D plus your C, which was the same thing, because here you have plus and you have a minus, right? So yes, now this is correct. So, and then now let's try and simplify this. So what you are going to be left with here, you are going to be left with your what now? This is going to be 9 into D subtract C. Now then, when you multiply by negative, this is going to be changed to B, negative B into what? Into, now what are you going to have? D subtract C. And what is going to be that? So which means you can still take out a common factor here. This is going to be D, subtract C as a common factor. You're left with 9, subtract your B altogether. And then now you are winning. This is now correct. This example 2. So what is it that we can do here, right? So now remember I said you need to start by identifying the pattern, right? So do we have a pattern here? Yes, if you can check here, you have 2a subtract 3b. Okay, it's fine. There's nothing interesting there. But look here, you have 4a squared subtract 9b squared. And now, is there anything that you can, recognize here? You have your b squared here, you have your a squared here, you have a square number here, which is 4, you have a square number here, which is 3. Yes, indeed, you have what we call what? A difference of 2 squares here, right? So which means, so if you have your difference of 2 squares, which means you can pair that. So now what is it that you are going to do? You are going to say, now listen, this is going to be same as now 2a subtract your 3b into bracket, and what? Into bracket, then what is it that you are also going to have? This other one is going to be now your open bracket, and remember there's a plus here, so this is going to be 4a squared subtract 9b squared. Sure. And now from here, since you had a difference of 2 squares, what is this going to be? Now this is still same as 2a subtract 3b. There's nothing important there, or anything interesting there. But look here, you have 4a squared. What is this? What is the square root of 4? This is same as 2a subtract what? Subtract 3b. Or this is same as 2a plus 3b, because this is your difference of 2 squares. Altogether. And now, if you can look at these terms, now if you can look at this, remember this is a term on its own, and also this is a term on its own. Is there anything that you can realize here? Yes, you can see that almost all of them, right? They have 2a subtract 3b, which means you can then now do what? You can then take out your 2a subtract 3b as a common factor. But when you take it out here, remember here it's same as 1, because 1 multiplied by 2a subtract 3b is still the same thing, right? So which means what you are going to be left with this, what you are going to be left with this side, it's going to be what? It is going to be plus, this is going to be plus what? This is going to be plus into, or rather this is going to be bracket into 1, and then plus what? Plus 2a, and then plus what? 2a plus 2b, isn't it so? Plus 3b, I mean, right? Because remember, you've taken out this as a common factor, so you're left with this one of 2a plus 3b. And then now, can you see that now this is what you are having? So is there anything that you can do to continue solving this? And then if there's nothing that you can do, and then you're going to leave it this way, because there is no any other thing that you can do now. So this is going to be your solution altogether. So you see how interestingly these things are. Let me just, try and get something else again that we can use. Let me wipe here. Now, let's say now you have this one, this problem here. Now, let's say now in this, this time around, I gave you that you have 25a squared. 25a squared subtract p squared. What? Subtract 12p. P what? PQ. And then what? Subtract 36 q squared. Q squared. Now we say factorize this fully. Surely this is example number 3, right? We are saying factorize this fully. So how can you factorize this fully? Now let's start here. What is it that we can do? if you can check in all this, here you have P, you have P, you have Q, right? However, all of this now, if you can check here, P squared subtract 12PQ subtract, 36 Q squared. This is a what? This is a perfect square. This is your perfect square. And so therefore, if this is your perfect square, which means you can group this, because now for you to find out what is going to be the perfect square, just going to look at what is the root of this and what is the root of that, right? And remember, this is going to be P, right? P, and then this is subtract. What is 36? It's same as 6Q. Out again. And this is going to be that, right? So now let's see in terms of what is it that we can do here. So now we're going to say this is going to be 25. 25a squared subtract now into bracket what? P squared subtract 12pq subtract 36 q squared altogether. And as I said, that this is your what is your perfect square, right? So this is actually same as what? This is same as 25 a squared subtract what is going to be this in terms of this is same as p subtract 6q, right? Squared. This is how you can also still write this. Now, however, now if you can check this one. Now, can you see that actually, let's say I represent this. Let me show you something. Now, look, let's say I represent this one here. Let me get a nice color. Now, let's say this one, I represent this as A, and I represent this entire bracket as B. Can you see that this is going to be what? This is going to be actually A squared subtract B squared altogether, which means this is a different of two squares, right? So which means actually these two terms, they give us a difference of two squares altogether. And so therefore, since this that is a difference of two squares, let me remove the a's now. Since those are your difference of two squares, what is it that now you can do here? So now you're going to say, what is going to be 25? What is going to be 25? Now 25 is same as what? 25a it's same as 5. What? 5a subtract what is going to be this? This bracket is going to be the same thing, isn't it? So this is going to be what? This is going to be actually into bracket p subtract 6q, right? And now you get it. Then the other one is going to be 5 what? Plus p subtract 6q altogether, because this was a difference of two squares altogether. And then now from here, then you can then see in terms of what you can do. You can just multiply with the negative here to multiply everything. So actually this, your final answer here, it's going to be same as 5a subtract p, isn't it? So subtract p plus 6q, isn't it, that this is going to be plus 6q, because this multiplied by this gives you your positive, and the other one is going to be 5 plus p subtract 6q, because here you are having a positive, so the positive is not going to affect anything altogether. So hopefully, you get to understand in terms of how do we do factorization by grouping, right? So I think we are going to stop here for today. Thank you.